why we are considering SQL backend technology. So because it deals with the applications. So it deals with applications. For example, when you sending the message through the Gmail, so what will happen? It will ask
Ma'am,
email
voice is
address.
cracking.
Ma'am, sorry.
Voice is cracking. Break.
So when you are sending the messages through the emails, just what will happen? It will ask the email address and password. Then we can see the process, but we cannot see the process server side. Are you able to hear my voice? So while working with the SQL, we cannot see the process on the server side. So here, what is SQL? Here we have some questions like what is SQL? We need to know some basic points like what is the database data. So what is SQL? SQL is a programming language for storing and processing the information in a relational database. So relational database stores the information in tabular form with rows and columns. So here you can see the example. So student table, right? So table has rows and columns. Columns represented by the attributes. So fields, objects. We can also call it as objects. And rows represented by the tuples, records, values. We can also define with the values. We can use the SQL statements to store, update, remove, and retrieve the information from the database. So why SQL is important? Why we need SQL? Why we need SQL? So SQL we can use with many programming languages like Java. So it is a structured query language frequently used in many applications. So most of the developers and analysts use SQL with programming language. They can embed SQL queries with programming language to build highly performing data processing applications. So it will follow some rules. Structured query language is not case sensitive. Using SQL statement, you can perform most of the actions in the database. So coming to the database, what is the database? So database is a collection of interrelated data which is used to retrieve the data from the table. So we can it and insert the data efficiently. So data is also used to organize the data in the form of tables, schemas, views, etc. Suppose we design the college database, what we have in the college. So college has admin staff. In the database, we can easily retrieve, insert, delete the information. So what is data? How the table can store the data? In the form of text, numbers, media, byte. So data is a collection of different small unit of information. It can be used in variety of forms like text, numbers, media. So for example, we have a car number. So car number, how it will. So car number it is a combination of the characters and numbers. So for example, if you take Gmail, so Gmail also has some special characters like @gmail.com. So we can add them. We can also add the numbers to the Gmail. And what is the DBMS? Coming to the DBMS, so database management system is a software which is used to manage the database. For example, MySQL, Oracle are popular databases which is used in different applications. So here you can see the example: student ID, name and address, field ID. So here we have columns. We can also call it as columns, attributes. ID, name, address, field ID are the attributes, objects. So 1, 2, 3, 4, and the table has values like Supraja. So here some values are there. So student and faculty, there is a relationship to maintain the student and faculty. So to maintain this type of relationship, so we need to create the college database or database, whatever we need the name. So just you can give that name. Next, what is coming to the RDBMS? What is RDBMS? It is a special type of DBMS. In this model, each and every entity we are represented as a relational model. Here you can see you can see examples, orders and customers. So orders table has order ID, product, total, customer ID. These are the attributes. So here some values: 1, 2, 3, 4, 5. So paper. So here customer can buy a next model. So what is the entity relationship model? ER model stands for entity relationship model. It is high level data model. This model is used to define the data elements and relationship for the specified system. For example, we design a school database. In this database, student will be an entity with attributes like name, address, ID, age. So address can be another entity with attributes like city, street, name, pin code, etc., etc. There will be a relationship between them. So here you can see the example: student represented by the rectangle attribute. Student is an entity that is represented by the entity can be represented by the rectangle, and name, address, ID, age are the attributes. So attributes are represented by the ovals. So here address also another entities because address have street name, pin codes like city. Next, here we can see the example of a relational database management system: student ID, student name, student address, mobile number, marks, and city, street, pin codes. So student ID, student name, student address, mobile numbers are the attributes, objects, fields. We can also call it as fields. Next, city, state, pin code. So this is the address entity at this. So here we have learned relational database. Relational database is in the form of tables. So we can easily understand if it is in the form of tables. Here we can see the non-relational databases. So non-relational databases are different from the relational database in that the data can be stored in the non-tabular form. So non-relational might be based on the data structures like documents. Here you can see the example, a document. So it is very difficult to understand. Next, what are the advantages of SQL? SQL has many advantages which makes it popular and highly demanded. SQL is reliable and efficient language used for communicating with the database. Some of the advantages of SQL are faster query processing. Large amount of data is retrieved quickly and efficiently by using the commands insertion, deletion, and manipulation commands in SQL. So no coding skills. For the data retrieval, a large amount of lines of code is not required. So in Java programming language, we have so much multiple lines of code, but no need to write multiple codes in SQL. Just we can write in a single line, just retrieve the data from the database easily. And all basic keywords such as select, insert, in, update are used in the SQL language. And also syntactical rules are not complex in SQL. So in SQL, which makes it easy, user-friendly language, and just so we can follow the syntax in the SQL, we can easily retrieve the data from the database. So portable, we can also use in many programming languages in PCs, servers, laptops, independent of many platforms. It is also embedded with the other applications as per need or requirement. So backup and recovery. SQL database have built-in backup and recovery tools that help to recover the data. In case of suppose user drop the table, just we can use the backup and recovery tools to prevent that situation. So data integrity. So coming to the data integrity, SQL databases enforce the data integrity by using the constraints such as unique keys, primary keys, and foreign keys, which helps to prevent the data duplication and maintain the data accuracy by using the constraints. So coming to the normalization, here important topic is normalization. So most of the tables and most of the tables are based on the normalization process, because we have so much duplication in the tables. So in that process, we can use the normalization. So what is the normalization? Normalization is the process of reducing the data redundancy in a table, improving the data integrity. Normalization process organizes the data in a proper manner. Normalization can be used for minimizes the duplication of the various relationships in the database. So it is a part of the relational database design because it helps to improve the speed, accuracy, and efficiency of the database. So we have some normal forms. First normal form, second normal form, third, fourth normal form, fifth normal form, bias score normal form. But most probably we can use first normal form, second, third, and BCNF. So coming to the first normal form, it does not contain any composite or multi-valued attributes. So a relation in first normal form, if every attribute that in the relation is single valued attribute. Suppose a person has two or more mobile numbers. So how can we store the data? So there is a duplication. So we have to convert it into first normal form. So if a person here, you can see the example person has two mobile numbers. So with the same ID. So we can we can store the data by conversion. After conversion of the first normal form, the mobile number stores the data with the same ID. So here student number, student name, student phone number, student state, student country are the attributes of the entities. So here some values, Ram, Suresh, and the mobile number. So here these are all the values in the table. So before going to discuss about the second normal form, we need to know some points, prime attributes, non-prime. What is the non-prime attribute? Functional dependency. So what is the prime attribute? Prime attributes are the that are the part of the candidate key. So prime attributes always have unique values within a relation, such as student ID and employee ID. So in the table, it will not accept the duplication of the data. Suppose if I enter the values with ID 1, suppose Sai. So again, I will enter the values with same ID, so it will not accept, because the prime attributes always have unique values within a relation. So what is the non-prime attribute? We have to know these points before creating the tables and before creating the database. So what is the non-prime attribute? Non-prime attribute the part of the any candidate key. So non-prime attributes may have duplicate values. So it can accept the duplicates. Suppose I enter the values with the same ID 1. So again I will enter the same ID, and third time also I will enter the same ID, so it will accept. So for example, age, gender. So age can the person. So different person have different ages. For example, age and gender. So functional dependency. What is the functional dependency? Functional dependency is a relationship that exists between two attributes. What is the rule for functional dependency? Non-prime attribute based on the prime attribute. So in the second normal form, what is the rule no functional dependency? So here what is meant by functional dependency? Non-prime attribute based on the prime attribute. So in the second normal form, the second normal does not have functional dependency. So 2NF should follow the first normal form. So in the second normal form, all the prime attributes are fully functional dependent on the. So here you can see the example: teacher ID, subject, teacher age. So here school can store the data of the teachers. Teacher can teach more than one subject, right? So teacher ID, subject, teacher age. So here the teacher age is the non-prime attributes, because one teacher can teach more than one subject, and teacher ages are also different. And here you can see the example: teacher ID, unique values, and subject chemistry, biology, English, maths, computers, and teacher age. So 30, chemistry teacher have age 30, and biology teacher also have age 30. So 35, 38, there is a duplication, right? So we have to, in that time, we have to decompose the table into two tables. So in the given table, non-prime attribute, teacher age is depend on the teacher ID, which is the proper subset of the candidate key. So that's why it violates the rule for 2NF. So the above table, we are decomposed into two tables: teacher ID, teacher age. So teacher detail table. So here the teacher ID, teacher age is are the attributes, objects or fields. So here some values: 25, 30, teacher age is 30, 35, 38. So teacher subject table. So here you can see the teacher ID and subject attributes. Teacher ID 25, 25, 47, 83, and subjects chemistry. So what is the rule for second normal form? What is the rule for second normal form? So no functional dependency in the table. So that's why we have decomposing into the two tables. So coming to the third normal form should follow the second normal form. So it should not have transitive dependency. So what is the transitive dependency? in the table non-prime attribute depend on the other non-prime attributes. So that is the transitive dependency. Here in third normal form, we have no transitive dependency. So here you can see the subject, subject ID, subject name, teacher age. So, what is the subject ID? 101, 102, 103, 104, 5, 6. So here you can see the subjects. Subject 1, subject 2, teacher name to teacher age. There is a transitive dependency in the table. Then to remove that, we have to create the teacher ID. So here the subject name, teacher age, there is some redundancy is there. So we have to decompose this table into other tables. So here after decomposition of the tables, you can see the examples. So subject table, what is the student ID? Student ID is the attribute and student name, teacher ID. So in the teacher table, you can observe. So teacher name, teacher age and teacher ID. So what is the rule for third norm? So non-prime attributes are depend on the other non-prime attributes. So that's why we are decomposing into two tables. So next, coming to the bias code normal form. So if the bias code normal form, it should follow the 3 and F. So prime attribute should not depend. What is the rule for the bias code normal form? So prime attribute should not depend on the non-prime attributes. So what is the prime attribute? So it has unique. It must has a unique values. So it does not allow the duplicate values. What is the rule? Prime attribute should not depend on the non-prime attributes. So here you can see the example: student ID, student name, teacher name. So one here Ram teaching the subject 1 in the student ID 101. So what is the rule? Prime attribute should not depend on the non-prime attributes. So here we have to create the teacher ID to remove redundancy. So here we have redundant values, right? Subject 1, subject 1. So the subject name attribute has so 2 or more duplicate values. So that's why we have to create the teacher ID to remove the redundancy. So student, after decomposition of the table, you can see student teacher table has a student ID and teacher ID and teacher separate table. Teacher Ram teaching the subject 1 in the value of 101. Coming to the keys topic. So what is the key? Key is an attribute that is used to identify the records in a table and also find the create relationship between the values. So here some keys: super keys, candidate keys, primary keys, foreign keys. So what is the need for a key? So keys and attribute are set of attributes which is unique used to uniquely identify the records. Here you can see the example: row number, name, course marks. Row number, course marks are the fields, objects. So table has columns and rows. So row number 1, 2, 3, 4 are the values. We can define the data as values. And next, super key. What is the super key? So here we can see the example: row number. Suppose we can take the row number as a key. So among Along all the keys, a name, course, marks are along with all the keys is called the super keys. The key attribute which is along with all the keys is called a super key. So super key is a combination of all possible attributes which can uniquely identify the rows in a table. Super keys may have null values. It is also accept the it has also accept the duplication of the values. So what is the candidate key? So here coming to the candidate key. So what is the candidate key? Candidate key can be defined as a set of one or more columns that can identify the record uniquely in a table. So here one advantage is so attributes of the candidate key can contain null values. So a table can have one or more candidate keys and also called minimal super key. One table can have one or more candidate keys. So here we can see the tables SID, student name, marks, and table 2 has student ID, student name, marks. So firstly we have to check the redundancy is coming or not. So student ID and S name. So student S1 student ID has S1, S2, S3, so S2. So and S name values A, B, B. So compare two columns. So we have to compare the two columns. Suppose if we are taking the S name and marks, there is some redundancy. That's why student ID and S name take them as candidate key. So candidate key can allow the duplication of the values. And candidate key never be null or empty. Its value should be unique. So the values must be present in the table for the candidate key. So there can be more than one candidate key in a table. So create here we can see the syntax. Create table, student, table name. Student is the table name. Student ID is the attribute, and integer. Integer is the data type. We will discuss in the data types topic. So just you can listen. So student marks are the numbers, right? So we need to use the integer data type. So yes, name characters. We can use the character data. So names has some characters. Like so, we need to use the character data type. So coming to the primary key. So primary key is which is used to uniquely identify a record in a table. Primary key in a table must have unique. So any column can have primary key. There is no rules to this column as a primary key. We have to define this column primary key. So there is no rule. Just any column in the table treated as a primary key. So here you can see the example: student ID, student name, student phone, student age. So what is the student ID? Says 1, 2, 3 are all the values. Okay. So I will create the table after discussing these topics. Okay. So first we have to know these topics. Next, primary key does not allow the null values. So here data types. Coming to the data types, what is the data type? Data type is an attribute that specifies the data that the object can hold. Suppose I want to store the names. So we need to use the varchar data types, and I want to store the numbers. We have to use the int data type. So if you want to store the price values, decimal values, we need to use the decimal or double. So string data types, here we have different types of data types, string data types and numeric data types and time data types. So here we have string data types, varchar data type and character data types. It has fixed length in the string that can contain the letters, numbers, special characters. The size in the character of size, the size parameter specifies the column length in the characters. So in the varchar data type, variable length string that can contain the letters, numbers. As we know the email address can have some special characters, numbers. So size parameter specifies the maximum length. So most probably we are using the varchar data type. Next, binary data type. It is similar to the character but stores the binary values. Size parameters specify the column length in bytes. So when we are going to work with the binary values, we can use the binary data type. So var binary also, it is similar to the varchar data type but stores the binary values. Next, numeric data types. What are the numeric data type? Numeric data types are used to store the numeric values in the values in the database. The most commonly used numeric data types are int, float. So int data type is used to store the whole numbers. So float data type is used to store the decimal value. Suppose we have price. So price, how can be the number? So it has the decimal values. Suppose for example 20.25. Here you can see the example. So it has some decimal values, and for price we can also use double data types, float data type, and date and time data types. Coming to the time data types, here we have four types: date, time, and timestamp. So date stores the date in the format instead of using the instead of the in the format. So date stores the dates in the format. It is in the form of years, months, dates. Instead of years, if you are using the months, so it will not accept. So it should be in the date format. Here you can see the format: year, month, date. So time format, it stores the time values in the format: hours, minutes, seconds. So the date and time combines the date and time: year, month, date, and time. So timestamp, it is also similar to the date time. So are you able to see my screen? Are you able to my screen? So are you able to see my screen? So here I am creating the program for the data types. Before creating the table, we need to create the database. So just you're using the create command to create the database. Create database. Create database. So I will give the name as class. So whatever the name you want to give another name, so you can give. You can also give another name. So here create database class. I will create the class database. Just select the query. Execute here. execute the query. So here no errors. You can you see the errors? So here one query is executed, success and 0 errors. So you have to refresh the. So here you can see the database. So I have created the class database. So now let me create the table with the using the data types. So I'm using create command, create table name. Table name I will give student. So student has some attributes like what? The student ID. I will give student ID. Student ID, what is the data type for the IDs, numbers? So I will give int data type. Student name. So I will give the student name. So name has some characters, right? So we need to give the varchar data type. So you have to specify you have to give the number. So it will specify the student name, length of the student name, specifies the size of the string. So I will give the student marks. So marks, how is the marks? The marks can be stored in int data type. So int data type is used to store the numbers, right? So that's why I will give the int data type for the student marks. Next, student ID, student name. Student ID is the attribute, column name. So student name also column name. Student marks also column name. So here int varchar int are the data types. Next, I will give the student age. Suppose student age int data type. So I will give sports column name. So here you have to give the commas. Sports data type. What is the data type for sports? Football, cricket. So that has the string, right? So for string, we have what we are using. So we are using the varchar data type. So you have to give the pixel length. Okay. Is it clear for you? So here, once again, I will explain. So I will use the create command to create the table. So create table. Here the STU is the name of the table. So student ID is the, what is the student ID? Column name attribute. So what is the S name? So S name is the attribute or column name. So these are all the column names. S ID, S name, S marks, S age, sports are the column names. So it will followed by the int data types. Int for I have given for SID int. So S name varchar, because it will be in the string format, right? So that's why I will give the varchar data type. So yes, marks are the marks are in the format of numbers. So that's why I have given int data type. So sh also in the form of numbers. So I have given int data types and sports varchar because sports in the form of strings, right? Football, cricket, some other games. So you have to execute the, let me execute the query. Just select the statement. Whatever you want, execute the statement, just select that statement only. Select the statement, just to click on the execution. So here the table has created. So how can we see the table? Is it created or not? So we have to use the describe keyword, describe command, describe table, describe table name, stu. So just execute the query. So just click on this. So here it will display the table it has created. So SID and name, marks, age, sports. So is that clear, guys? So how can we create the table and how can we? Okay. So how we created the table? So we have to use the create command to use the data to create the database. So here I have given the name class name. So in that class name, I have created the table, student table. So here student ID, name, marks, age, sports are the column names. Okay. So after creation of the table, if you want to see the table, just use the describe command and a table. You have to give the name of the table. Just describe table. Just give the describe table. Just it will display the table. So are you able to see the table? Are you able to see the table? So here left side we have database names. So here I have created the class database. So here database names. Just every time if you have done any modifications, every time you have to refresh the. Every time you have to refresh. So thank you guys. Tomorrow we will continue. So did you understand create table? How can we create the tables? Create the databases? Okay, thank you so much. Thank you. Okay, thank you.